Yo, YouTubers. That's something we said in New Jersey. Yo. Like, how you doing? Yo, YouTubers. I like it. So, today I want to talk about notes for teachers a little bit. How do we deal with the volume of a sphere in synergetics if we have this different unit volume, right? We have the unit volume tetrahedron that connects the four spheres in a tight packing, makes a tetrahedron. What are we going to do about the sphere? Well, you know we have a conversion constant by now, right? The second root of 9/8 is one way to put it. So if you multiply the sphere volume formula 4/3 pi r to the third power by the square root of 9/8, it simplifies to the square root of 2 times pi r to the third power. So that's okay. You just take that. That's what these teachers' notes are about. You take that number for the unit sphere, and if you divide it by 6 to get the sphere to void ratio, because remember, these guys fill space. Your rhombic dodecahedra have the spheres inside. So any space not accounted for by the sphere will be accounted for by this guy. And so sphere divided by this guy is what we call the density of the packing, which is about, what, 0.74048. 0.74048. You can Google that and you'll find that in XYZ accounting it's the same answer as you would expect, because when we're ratioing these guys to each other, we always get the same answer. Like XYZ and I both agree that if the short diagonal of my rhombic dodecahedron is equal to that of the cube, and if the tetrahedron has a volume that's also, the tetrahedron has to have an edge that's the same as the face diagonal of the cube, which this one does not. I'm looking around here for my other tetrahedron that's the right size and made the same way as this guy, but it may have bit the dust. I don't know. These are old. These are old. The cube has got this tape patched on it and stuff. I kind of still use them just because they're old friends, but nevertheless, you could make some new stuff. That brings me to Facebook, where I'm also sharing these notes, and to the fact that you can divide up, just because rhombic dodecahedrons fill space without gaps doesn't mean other shapes don't too. We all know the cube does. So by reapportioning the volume of the rhombic dodecahedron, you can get cube octahedrons alternating with octahedrons to fill space, and you can also get truncated octahedrons all by themselves to fill space. And I think Casey House does a really good job. He's got a whole collection of useful posters here. Now, how can I just see the posters? Okay, how about art design? Lots of cool stuff. Worth a visit, eh? I'll put a link in the YouTube comments. All right, so remember, sphere, volume formula, square root of 2, I say with ambivalence, because I'm training myself to always not think of squares and cubes when I'm doing synergetic geometry. So second root of 2 times pi times r to the third power, radius to the third power, is your volume of sphere. All right, talk to you soon.